Right, so the first one says, the horizontal line y equals 2 is an asymptote for the graph. So what that means is whatever this graph does in the middle, it's going to level off at 2 on either side. So which of the following statements must be true? Well, if it levels off at 2 on either side, that means the limit to infinity is going to have to be 2. So that one is going to be E. All right, this one says the limit as x approaches 3 of some function is 7. Which of the following must be true? Now, just because you have a limit at 3 does not really guarantee you much else. All this means is that at 3 on the x-axis, the graph approaches 7. So it doesn't mean that there's actually a point there. It doesn't mean that your graph is continuous, and it doesn't mean that your graph is differentiable. Differentiable means we didn't get like a sharp edge there. Remember the absolute value graph we did and it had like a sharp edge, we couldn't get a derivative there? You're not guaranteed any of these things. You might have a hole there, you might not be differentiable, can't get a derivative, you might not have a point, so you aren't guaranteed any of those things. So none. So just because you have a limit doesn't really mean that you have much else. All it means is that there's behavior of the graph. So both sides approach the same thing. But you don't really get much else from just a limit. All right, and I just remembered I actually shouldn't be writing on this piece of paper because I'm gonna have to use it with my other classes. So let me switch real quick to writing on a separate piece of paper here. All right, number 3. Function is continuous for all real numbers. What is f of -2? So we have to know where the graph is headed at -2. And we're going to have to factor the numerator. So that'll be x plus 2, x minus 2. And the x plus 2's are going to cancel. And when you plug -2 in for x, you're going to get -4. So that one is A. And you guys probably noticed some of these were repeats of the homework questions you've done. This was one of them, and you'll see a few others on here as we go through. All right, number 4, limit as x goes to infinity. That is who's in charge here. So for the numerator, it's the x squared. For the denominator, it's the -4x squared. And since those are a tie, we're going to use the coefficients, which would be 1 over -4. So that one is B. Oh, what was 2? Let me go back to that one. 2 is A. Just because you have a limit does not guarantee you any of those other things. All a limit means is that both sides of the graph approach the same value. It doesn't mean that you necessarily have a point there. So you don't get necessarily any of those other things. All right, so 5 is another one, limit going to infinity. So, or no, I'm sorry, that's not infinity at all, it's 0. Okay, I'm sorry. Let's try to plug in 0 then. If you plug in 0, you're going to get 0 over 0, which is indeterminate. So that means that there is a hole. We're going to have to get something to cancel out. And so I'm going to have to do some algebra to get something to cancel. So out of the numerator, I can factor an x squared. That'll leave me with 5x squared plus 8. And same thing in the denominator, that'll leave me with 3x squared minus 16. And so these cancel. And now when I go to plug in 0 to the numerator, that would give me 8. And to the denominator, that will give me -16. So that'll be -1/2, which is A. All right, number 6. Okay, this is another one that's to infinity. So that is who's in charge here. The thing is, it's all factored apart, so I'm going to have to multiply this back together. So let me multiply these together. That will give us 6x minus 2x squared minus 3, and then plus 1x. Those negatives are going to cancel. And in the denominator, I'm going to have x squared plus 3x minus 1x minus 3. So I had to multiply all that back together to be able to see all the powers. And so who's in charge of the numerator is this term. And in the denominator would be this term, just the x squared. So since they are a tie, we're going to use the coefficients, which would be negative 2 over 1. And so that would just be negative 2. And so that one was B. All right, 7, another one going to infinity. So again, it's who's in charge here. The numerator would be the x cubed, denominator would be the 4x cubed. Again, it's a tie, so using the coefficients would give you 1/4. So that one was C. All right, number 8, we're going to need a calculator for this problem. I typed that in there, so if you want to grab your calculator, you're going to need it here. It says the graph of a function f is shown. The value of limit as x approaches 1, sine of f of x. Okay, do you guys remember that like f of g of x stuff, composite functions? You start with the inside function, and then whatever you get gets passed along to the outside function. So we're going to start with the f of x, which is this graph here. So we're going to do limit as x goes to 1 for this graph. So what is the limit as x goes to 1 for this graph? Just by typing in the chat, what is that going to give us? Yeah, good, cool, it'll be 2. I realize the actual point's somewhere else, but the limit both sides are approaching is 2. So what we have for this part is 2, and so what we want to do is sine of 2. Now that's not on the unit circle, which is why you need a calculator. The other way you always know when you need a calculator, if you're like, how do I know when I need one? Look at all the answer choices. If they're all crazy decimals, then you know you're going to need a calculator. So going to our calculator, we need to make sure we're in radian mode, which you should be unless you've messed with it because it's the default mode. But if you go to mode right here, just make sure radian is highlighted. And I'm going to do sine of 2, which gives me 0.909. And so that one is A. And remember, you always need 3 decimal points of accuracy. All right, number 9, limit as x approaches A. That's a little tricky because A is not a number, but if you try to plug in A, you're going to get a squared minus a squared, which is 0. And then down here, a to the 4th minus a to the 4th, which is 0. So again, indeterminate, that means there's a hole. We're going to have to do algebra until we can get something to cancel out. So the numerator, I'm just going to leave alone. The denominator, I'm going to split. So x to the 4th is going to be x squared and x squared. A to the 4th will be a squared and a squared. And we'll have plus and minus. So it's a difference of squares. It's just it was to the 4th. It was like squared squared. So these are going to cancel. Our numerator is just 1. And then we can plug in a. So down here, we're going to have a squared plus a squared, which would give us 2a squared. So 1 over 2a squared, which would be b. All right, number 10. The figure above shows a graph of a function f from 0 to 4. Which of the following statements are true? All right, let's see. Limit as x goes to 2 from the left. Well, 2 from the left would be wherever this hole is. They didn't label the y-axis, so I don't know exactly what it is, but it would exist. And limit to 2 from the right would be wherever this point is on the y-axis. Again, it's not labeled, so I don't know what it is, but I know it would exist. So from the left and from the right, we're good. But overall, the limit does not exist because there's a jump there. The two sides are not coming together at the same point. So we would get Roman numeral 1 and 2. And so that would be C for that one. So 10 is C. All right, 11. This is another one that's a repeat from the homework, and 10 was C. Let me just go ahead and write that down. We want to make this function be continuous at 2. So for continuity, you want to set the two parts equal. And what's kind of nice about how they did this one is those x minus 2's are going to cancel. So when you set this equal, you'll just have 2x plus 1 equals k. And they said they want it at x equals 2. So I'm going to plug in 2 for x. And if I plug in 2 for x, that's going to give me 5 for k. So that one was E. Right, here is number 12. It says a function f is defined from 0 to 8. This is the derivative that we're looking at. So this is not the graph of f of x, this is the graph of f prime. So this is the derivative graph. They tell us the point 35 is on the graph of f of x. Again, that's the one we're not looking at. An equation of the tangent line. All right, to do an equation, you need two things. You need a point and a slope. And they gave us the point. They said that the point was 35. What we need to figure out is the slope. Now the slope comes from the derivative, and we want the derivative at this x value, which is 3. So I need f prime of 3. And they gave me the graph of f prime. So looking at this graph, guys, what is f prime of 3? I think we're all feeling shy there. Oh, Victoria answered good, 2. So here's 3. We're looking for where that hits on this graph, and that would be 2. So f prime of 3 equals 2. And so this is my point, this is my slope. I'm going to put them together and write an equation. So y minus 5 equals 2, and then x minus 3. Sometimes your answer choice will look like that. Sometimes they'll rearrange it. So let me look at the answer choices. It looks like they left them all alone, which is nice. We don't have to do any more work. So y minus 5 equals 2, x minus 3. That is C. All right, 13. We're going to need a calculator for this one as well. And I put a hint. Remember how to find a derivative on the calculator. So we'll go through that again. So an equation of the tangent line to this graph at the point 0, 1. So again, for an equation, you need a point and a slope. And the point they gave us was 0, 1. So slope comes from the derivative. We would want the derivative at 0. Again, it's at that x value. So I want to find f prime of 0 for this function. So let's go over how to do that in the calculator. And I am eventually going to teach you how to do this without a calculator, but for right now, we're going to need it. So it is in your math menu. Math is right here. And it's math 8, but if you forget that, you can scroll down. It says derive. So I want math 8. Just hit your variable key here, d dx. That just means take a derivative. And our function is x plus cosine of x. So I put the function in there, and then the value where we wanted the derivative is the x value, which is 0. And that will give us our derivative, which is just 1. So my slope for this line is just going to be 1. So again, it's math 8, and you type in the function and then whatever value you want to find it at. So this would be y minus 1, my y value, equals my slope, which is 1, and then x minus 0. I can pretty much guarantee they didn't leave the answer choices like that. I'm sure they got y. Yeah, they got y by itself. So let's sort through this. This side would just be 1x, because then this would be minus nothing. And then if we add over the 1, we get y equals x plus 1. So that looks like B for that one. All right, and then I can fit 14 and 15 on here. Let's see. 14. This is another review of a homework problem that you guys did. It says the graph has a horizontal asymptote at 2. That means that means A is going to have to be 2. If we have a horizontal asymptote there, we're going to have to level off at 2. So that coefficient is going to have to be 2. And if we have a vertical asymptote at -3, C is going to have to be 3, because x plus 3 is how we would get a vertical asymptote at -3. So A is 2, C is 3. We want to add those together, so 2 plus 3 would give us 5. So that one is E. And then last one. Limit as x goes to 2 for this function. Now, there's a break at 2, so we're going to have to plug 2 into both pieces of this. So we're going to do limit as x goes to 2 from the left of the function, and we're going to do limit as x goes to 2 from the right of the function. And if these are the same, then that's our answer. And if they're not the same, then it would be does not exist. We wouldn't be able to get an answer. So 2 from the left. So I'm going to plug 2 into this piece of the function. And that would just give me ln of 2. Whatever that is, that's going to be some decimal. Without a calculator, I don't know exactly what it is, but I just know it's some number, ln of 2, whatever that is. And then 2 from the right means we're going to use this piece of the function. So if I plug in 2 there, 2 squared is 4. I'm going to get 4 times ln of 2. So again, I don't know what that is either, but it's some kind of decimal. I just know that this is 4 times as much as that. They are not equal to each other. So the limit as x goes to 2 overall is going to not exist because the left and the right did not match up. And so that one was E.